Hello guys, let's try to answer this question. So the question is saying figure 7.1 shows a swinging pendulum in three different positions, at position A and at position C. The pendulum bob changes the direction in which it is moving. So we have position A, this point A. We also have position B and C. So the pendulum bob is changing the positions. Okay. So the first one is saying, which is question A, state the position A, B, or C at which the pendulum has the least potential energy. So to answer this one, let me just try to give an example. If we have a building here, suppose this one is a building, then this one is the ground surface. So on top here, if we are having a ball, suppose this one is a ball, and this ball is having the energy of 20 joules. So on top here, we are going to find that the potential energy is going to be 20 joules. Then when it comes to kinetic energy, it is going to be 0 joules. Okay. Why are we saying like this? You're going to find that as for the potential energy, it is going to be determined by the height. So this one here, it is the height, which we are denoting by it by h. Now let's just imagine that if we drop this ball here down, or the halfway of the building, so how much energy are we going to have for the potential energy and the kinetic energy? So the halfway of the building, you're going to find that the potential energy is going to be equal to the kinetic energy. Now we know that the total energy is 20 joules, meaning potential energy at this point, it is going to be equal to 10 joules. Then when it comes to kinetic energy, also it is going to become 10 joules. So once you add, you're going to get the total energy, which is 20 joules. Let's imagine if we drop this ball up to the ground, what would be the potential energy? So at this point here now, it will be different now. The potential energy is just going to become 0. Then the kinetic energy is now going to be the maximum one, meaning the kinetic energy is just going to be 20 joules. Right. So when they use the term which is this thing, meaning where we are not going to have maximum kinetic potential energy or no potential energy. So let's just imagine at bob B, here the ball is going to be in equilibrium, meaning at rest. If here we are having the ground. So I'm from saying that on the surface ground, the potential energy is just going to be 0. So now let's just imagine that here we have the height. Even here we are going to have the height. Meaning at position A, we are going to have maximum potential energy and least kinetic energy. Even at point C, we are going to have maximum potential energy and least kinetic energy. So meaning the answer is just going to be B. Why are we saying B? Because here the ball is at equilibrium state or at rest, meaning the potential energy is just going to be 0. So we can say position B. Then question B. The pendulum takes 1.6 seconds to swing from position A to position C. Calculate the period of the pendulum. So the first thing here, you need to know the formula that you're supposed to use. So the period of the pendulum, denoted by T, is going to be equal to the time taken over the number of oscillations. So the time taken that we have here is what? 1.6 seconds. What about the number of oscillations? The number of oscillations, we are going to get them from the moves that this bob has taken. So the bob moves from point A up to point C. Now, how many moves do we have here? So from A up to B, we are going to count this one as 1 move. Then from B up to C, we are going to count this one as 2 moves. Now, for a bob to make one complete oscillation, it needs to move from point A up to C and back to A, meaning that one is going to be one complete oscillation. When a bob complete one complete oscillation, it is going to make the number of oscillation as 1. Now, for us to know the number of oscillations that we have here, since we know the moves that this bob has taken, which is 2, divided by the total probability or the total moves that the bulb is going to take for it to complete one oscillation. So from C back to A, this one is going to be 3 moves. Then from B back to A, this one is going to be 4 moves. So for a bulb to complete one oscillation, it is going to move 4 moves. So we can divide by 4 here. As the result, the answer is just going to be 0.5. So 0.5 is the answer that we are going to get now for the number of oscillations. We have known now the number of oscillations that we have here. So we are going to say the period of the pendulum is just going to be equal to 1.6 seconds for the time taken divided by the number of oscillations that we have, which is 0.5. So when I divide here, I'm going to get 3.2 seconds. Usually, as for the period of the pendulum, it is measured in seconds. So that is it. Thanks for watching and see you next time.